Hi, my name is Mahbub Haq, and I am going to talk about a design pattern for software engineering, and it's called the object pool pattern. Now, I used this pool pattern and discussed this in one of my other classes, but I'm going to go ahead and discuss this in a little bit more detail here with an example, some advantages, some disadvantages, and what this pattern actually is. So let's get started here. What's happening? Okay, the introduction, the intent. So basically what this pattern is, it is a creation or design pattern that keeps an already initialized set of objects in a pool. So pretty much this is a design pattern that we want to use where the instantiation of a resource is very taxing, right? If we have a large number of resources that we want to use, but each resource takes a large amount of time to instantiate, the performance can degrade for the application, and it could be a bad experience for the user, right? So there are two different types of implementations for this pattern here. One type of implementation is the limited resource, right? We have a number of resources, but they are limited. We cannot have any more of that resource. So if an object goes ahead and tries to request a resource, but there are no resources available in that pool, which means all the other objects in the system have already requested these resources, the object that requested this resource must wait until another resource has been released and brought back into the pool of objects. Okay. Another implementation here is, of course, the unlimited resource. So this is where a default number of objects have been instantiated, say 5, whatever it is. There's a default amount that has been instantiated when the system starts, and then an object requests this resource, but there are no more resources available. So what happens here is a new resource is instantiated and returned to that object, always. So it's not like an object has to wait. However, that object has to wait until, of course, the resource is instantiated. And once that resource has, that newly instantiated resource has been instantiated, it is now included as part of the pool. So if we originally had a pool of objects with 10 resources in it, we instantiated a new resource, there's now 11 in the pool, and these 11 will now be used among all the objects that want to request this resource. Okay, so let's go on to the next slide here. So let's talk about a few advantages of this object pool pattern here. One of the advantages, of course, as I have said, is performance. Of course, when a system first starts, there is that lag to instantiate all those resources that to be put into the pool to be used for later. So, I mean, there are some ways to alleviate this when the system first starts. I mean, care should be taken that this pattern, ideally should be used in a system where this system is kept alive for a long time, right? It's not just the system has to be restarted every time a user sits down in their desk or something of that sort. Also, care should be taken when implementing this pattern, because one of the disadvantages of this is memory, right? So all of the resources that are instantiated, they are kept in memory. If each resource takes a large amount of space and there are a number of resources that we need, the system might have trouble allocating memory for other processes and other functions that it needs to keep in memory. So again, care should be taken. I mean, this pattern ideally is used for a system where the system is kept alive for a long time, and where the resources that are used in that system to be used in this pattern do not take up that much memory. I mean, they can take up much memory, but it is all dependent on the system. So I provided an example here. So let's talk about this example in a little bit of detail. So suppose we are in a work environment and there are a number of files that each user needs to access. Okay. So in order to gain access to this file, the application will send a request to the web service, which the web service will go back to the database and get that file text and then return it back to the user or the application. So the instantiation of this file can be very taxing. First of all, we have an unpredictable time for when the request is sent to the web service, right? The time that this takes is dependent on a load of factors. I mean, including the network connection of the building at that time. Also, the number of requests the web service is already trying to handle. The more requests the web service is trying to handle, the more time it will take for any additional requests that come to the web service for it to execute. The same can be said for when the web service is returning the file back to the user. Now, getting the file text back from the database also has an unpredictable time, right? So it is dependent on such factors like the number of files already in the table of the database. I mean, the query that needs to be executed can take a long time if there's like millions and millions of records in there, as well as additional functions that need to be executed to prepare that file text to be sent back to the application. This can all take an unpredictable amount of time. So instantiating a file to be edited, it's taxing. So it makes sense to use an object pool pattern here, where we keep a number of resources in the pool, in the system application, where users can go ahead and request a file and it is already there in memory and they can use it. Improves performance a lot. Now, there is another functionality this object pool pattern implements is once a resource has requested that resource, it cannot be modified. That resource cannot be modified by any other objects because they must request it. They'll see that it is locked by another object and they can't modify the resource. Now, this is not the main intent of the object pool pattern, but this can also be another reason to implement the object pool pattern if you have a system where resources should not be modified by several different objects at the same time, thus causing inconsistency to the display of information to the end user. So again, going back to this work environment of the file, so basically once a file has been requested by a user, they are using it. Another user desires to modify this file, but it sees that it is locked by another user. He has to wait until that resource is back. So this is a limited resource implementation. So the benefits, of course, it can offer significant performance boosts as all objects are already instantiated and are reused. The pooled object is obtained in predictable time. Again, I was talking about that unpredictable time when sending request to a web service and retrieving the file back. There are several factors that can go on here. Here are some more disadvantages to this object pool pattern. Since all objects are already ensured that they can handle memory usage, so I have discussed this. It is easy to forget to clear and reset the object when the client is done with it. So another implementation of this object pool pattern is when you are returning that resource back to the pool, we have to make sure that it is returned back as a ready state, right? So suppose going back to that work environment here, I am done with the file, it is saved, I am returning it back. But this object that I'm returning back has all my credentials, right? My user ID, my several properties that go with the user. It is all there as part of the resource. So when I return it and somebody else requested, they have all the information now that belongs to me. Right, so sometimes when care needs to be taken when implementing this pool pattern, that we should take care to reset that resource so that it can be reused again back in its stage. Another disadvantage is the objects are not handled properly when returning back to the pool. It may cause memory leaks. So known uses, I use my work environment there as a simple example, but it is commonly and very widely used for game design, accessing and receiving several textures, images, objects, sound files, etc., managing documents, managing inventory. I did provide a demo example in the application, but I will go ahead and just describe this instead of actually displaying this. But pretty much we have a library that has two different books that are limited edition, right? So the library cannot order more, it's limited. So book A has quantity 5, book B quantity 10. So suppose a person comes into the library, they want to request this limited edition book. So if book A, if the quantity is still there, like 3, 2, or 1, the library gives it to them. But if there is no more left for book A, that user or that person, they cannot get that limited edition book. They will have to wait until somebody else comes back to the library, returns that book. Okay. Another implementation is the unlimited, right? So suppose we have an unlimited amount of books. Well, not really unlimited, but we have a default amount of books in the library, but we can order more, right? So it's basically like an unlimited resource. So in the library, suppose I have 10 books of book A of type book A here. A person comes in, they wants to get this book, but there are none left. What the library can do is that they can order that book, right? It'll come back from the vendor, and then a day or two. But for the sake of this example here, we're just going to assume that the book comes immediately. Okay. So the library orders a book, it comes, and they give it to the person, and they leave. But now this is part of the library, right? They ordered it, it's part of the library. So now the library has a total of 11 books. So that is an example of how unlimited works here. So yes, that is my explanation of the object pool pattern. Thank you.